This is Andrej Kyselica. I'm a cloud solution architect with my colleague Kyle Burns. We're both based in the area on the Azure customer success team within Microsoft. So with our jobs, we have the opportunity to work with organizations that are taking their first steps into the cloud or making major advancements in their cloud footprint. So this is a lot of what we do day to day is helping organizations get the benefits of the cloud. And I think at first, a lot of organizations end up copying what they do on premises into the cloud and from a process and infrastructure perspective. And I think Kyle and I were chatting a little bit before. Pradeep's session does a really good job of setting the table in terms of some of these more agile cloud native development processes and deployment processes. They're going to help make your organization more successful. So Pradeep outlined a lot of the concepts that we'll be talking about here. In this session, I'm going to drill in and show some examples of how to do the tooling around some of this using at least one stack. And obviously there's others out there. The other perspective we have on this is Microsoft as a company itself, right? We went from a company that shipped a product in a box on a DVD every 2 to 3 years to shipping a service that's updated constantly and deployed around the globe, right? So with that change in how we operate, we learned a lot and that changed the way we work, right? So a little bit of what we'll bake into here is our learning. A little bit is what we learn from our customers, and hopefully it'll be helpful to you. In terms of tooling here, like I said, I'm going to show one set of tools and stack. I don't think it's as important necessarily the particular tools we're using here, because there's other tools that do things in similar ways. I just think the concepts that you'll see here will apply and roll consistently across other things. So before we dive in, let's kind of step through a little bit of some principles and concepts. And like I said, I think Pradeep did a really good job giving you an overview of what some of those things are. So I hope you saw a session. But we think about DevOps and the core principles, at least in Microsoft, is the first one is customer centric, right? Is it doesn't really matter what features you have if your customer is not using them or not successful in using them. It doesn't matter what's on your roadmap until it's actually deployed and providing your customer value. So we're very passionate and focused on measuring the impact and value that our products have and the value our customers are getting out of it, not just the fact that we check the box on the feature grid. Another principle from the product and team perspective is end-to-end ownership, right? We've organizationally, and a lot of organizations we've worked with as they've gone down this journey, it's been a change in the org chart, and it's the fundamental concept that's driven that is end-to-end ownership, right? Have a fewer number of people responsible for the end-to-end delivery of a feature and capability within a product to the customer, instead of aligned towards horizontals like database, web front end, or on operations. Another principle, almost everything is in source control, right? The source code is a single version of the truth. So whether it's the logic of the application and how it executes, or how it's deployed, or how the infrastructure is defined, as much of that as possible is in source control. I say almost there because there's a few things that aren't in source control intentionally, right? Secrets and keys and API endpoints, by definition are configuration and need to be stored in a different place, right? So almost everything is in source control. We want to automate almost everything. We'll talk about that in a little bit and talk about why, right? The other thing we've seen a shift is a big focus and investment in monitoring and operations, right? Like in the on-premises world of I run servers and I SSH into them to deploy and fix things. Monitoring isn't super important. In the tooling and telemetry on my application, if I'm just promoting into the machine, I can get access to that, right? But by separating the production and operation of that service from the people that build and deliver it, there's a lot of value in good tooling and telemetry. We'll talk more about that. And the other principle is iterate everywhere, right? You'll see a lot of stuff here, and maybe you're close to lining with these principles, and there's always an incremental opportunity. And my recommendation at the end here isn't going to be where do I want to be in 3 years, right? That's too big of a chunk to bite off. You want to have some vision there. But think about how you can take one step towards improvement, right? What's that one thing I can do in the next sprint or the next 2 sprints and bake in? Because your product owners aren't going to give you a couple months off to work on infrastructure and delivery and platform, right? Like you're accountable for features and delivery of the capabilities of your product or to your clients' deliverables. So this is something you can do in one step, right? So how do you iterate? So let's step back, talk a little bit more about automation and why it's so important. I mean, obviously, we as developers by nature are lazy, right? I think that if I can write a script, a tool to do something for me, then that's going to make me more efficient. And developers hate doing repetitive things, right? So I think since the beginning of software development, there's been a discipline and desire to automate as much as possible. So that's not a new thing, right? So why are we talking about automation so much in DevOps? And I think it's all these other things, right? It's consistency. It has to be done the same way every time without variation, right? And the way of doing that isn't documented in a binder somewhere. It's documented in the automation runbooks and scripts that deploy this consistently the same way every time. We're going to deliver with higher quality, right? Because even doing things 99.99% of the time correctly is still going to create situations where you have an unacceptable level of failure. Pradeep talked about the worked on my machine scenario, right? As the configuration of things get more complicated, it's really important to have an immutable deployment model, a way that things get deployed that don't rely on the configuration of any particular devices. Because in the cloud world, machines come, machines go, right? So the journey that a lot of organizations make when they go to the cloud is a move away from this idea that I build servers and fix them when they break, to a model of I don't really think about servers as a persistent asset, right? Like if there's a problem with something, I'm going to replace that infrastructure. I'm not going to try to fix it. The other one is security, right? Having production level access, standing access, is becoming harder and harder in the modern regulated world, right? You have to have a really strict accountability for people that have production access to customer data or personal identifiable information, or if you're in healthcare, like health data, right? So the data organizations talk about data toxicity, right? Is how dangerous is that data? If you don't have automation and you rely on people remoting into things and doing things manually, you don't have the very good ability to create those security barriers. So the more modern model is the tools have access to the environment that the people don't, right? And if people have to access the environment, that's an exception. And the last one is I like this quote. It comes out of our team that builds one of our SaaS services, is if it hurts, do it more often, right? A lot of the organizations I work with, they're kind of stuck in this semi-annual or quarterly deployment process, and it's such a painful event, right? It grinds everything to a halt. And I think that my recommendation for them is, their instinct is like, let's deploy less often because it's so hard and so many things break. Is, well, then let's deploy more often, right? If it's quarterly now, let's make this monthly, right? Because it's going to force a certain discipline on you, and it's going to turn deployment from a stop the world event to something that happens all the time, right? And that's really what happened with our journey on a lot of these box products that we turned into cloud services. All right, so a quick talk about tooling, and this isn't a kind of product presentation, but I want to explain what we're using here, just so you understand. And so for our pipeline and build automation here, we're using Azure DevOps, which is a cloud-hosted CI/CD developer support solution, right? And it's called Azure, but it's not really tied into Azure in any specific way, right? I mean, we obviously want to have good tooling and make it easy to deploy things to Azure, but you can deploy on-prem to Google, AWS, or any other cloud with Azure DevOps, right? So it's not really about Azure, it's about the tooling and automation. So Azure DevOps in the house has pipelines. So that's a cloud-hosted CI and CD tool set. It also has test automation and test management, issue tracking, built-in Git repos, and artifact storage. And the nice thing about it is you can use as much or little of that as you like, right? So I'm going to show a project where our code is in GitHub, and we're using just the pipelines in Azure DevOps, right? We'll show another project, some open source projects that are using just the pipeline features for their testing and automation. The reason I use Azure DevOps on a lot of my personal projects and side projects is this generous free tier. So we have 30 hours of build per month. So that's Windows, Linux, and Mac VMs that are doing build automation for you at no cost. Unlimited private repos, and if you have 5 people or less in your project, essentially you get all the enterprise features that you would want, and you don't have to pay, even get your credit card out. For open source projects, is a more generous tier. There's no limit on build hours, and up to 10 parallel build tasks. So this is great for, we'll show projects that have to support a lot of different platforms. If you want to do building and testing across a matrix of different versions of Python, different operating systems, that can be a huge test matrix, and that's really where Azure Pipelines and Azure DevOps make things really nice and easy. All right, so let's jump over to a demo. Okay, so that's enough slideware for now. So I have a project here. This is a very simple Flask web app. It's stored in a GitHub repo right now, and that's really, there's not that much to it. So the first thing I'm going to do is I'm just going to run this thing locally. Oops, slides out of the way. I'm going to run this locally, and we're going to talk about some of the things that Pretty showed in his presentation, right? So the first thing about projects, I already have a couple things baked in, right? I have requirements.txt. So all the dependencies of my application are defined and declared, and this is fairly mainstream in the Python world now, right? So everything that I need to deploy is not just installed manually in a bespoke way. I'm also using virtual environment or virtual env. So I'm going to install that. I'm going to run this locally right now. So use my typing. So first I'm going to create the help if I. Okay, so this is going to create my virtual environment. I'm going to activate that environment next. I think WC Fields had a good line. He said they don't work with animals or children. I think if he was in the modern world, he'd say he doesn't do live development demos either. So I'm going to activate that virtual environment. Scripts. And then I'm just going to paste this in because this is a lot of typing. I'm going to set environment variable. So this is basically, I have to set environment variable. So Flask knows how to start my application. And then I'm just going to run it right now, just to show you what this app does. It doesn't really do anything that fancy. Oh, I forgot a step. Didn't do my pip install. So let's do that. Okay. That's going to install all my dependencies. Requirements text. So right now, this is the hand deployed model, right? If I was working in the old school way of rolling things out, I could do this on a server and deploy my application, and it's going to run just fine, right? So got my code and my API returns a number. Okay, so hello world running in Python on my machine. I'm going to deploy this manually just to show you what we're going to do, what we're going to automate. I'm also going to deploy this to Azure. So Azure has a service called App Service. So it's basically a, think of it like a web server as a service. This is going to run on Linux. It's going to be containerized. I'm going to just paste these commands in because they're pretty long, but I'll show you what this does. This is going to, just the Azure command line, web app up. So that's going to create a web app. That's the name of the app. That's the SKU I want to use. That's going to take it a moment to run. And then I've got to do one more step after this. And we're not going to sit there and watch that for a second. I want to talk about our next phase of this, because this is going to take a few seconds. All right. So let's pull up Azure DevOps and look at my Azure DevOps environment, right? So this is the GUI for Azure DevOps, and this is a SaaS service, right? So I don't have to deploy it and run it. I just sign up for a free account, and I'm using it. We're going to use the pipelines feature. So everything we've done there, we're going to automate through a new pipeline, right? So these are a couple of example ones that I have out here. So while that's running, I'm going to start the next step, right? We're going to just assume this is going to work. I'll show you the app, but I don't want to have to wait for this thing to finish. So right now, I haven't really kind of embraced any kind of automation here, but let's take the first step. So in Azure Pipelines, to build a pipeline, kind of the best way to do it is to create a Azure pipelines.yml file. So this is basically a declarative script for how my deployment runs. And I just have like a hello world pipeline here. So let's talk about what this does. So this YAML file is basically a recipe, right? This is in source control alongside my project, and this is a recipe for how I want this thing to run. So let's take a look at it step by step. And if you use Jenkins or other tools, there's kind of a similar concepts here, right? This is version alongside it with my code. So the trigger is on master. So whenever the master branch changes, I'm going to set some variables here. I'm not using these yet. I just pasted this in to save us a little bit of time. And then I can have multiple jobs defined in here, right? So this is just a hello world job. And so there's the name of it. There's the title of it. This pool is an important, interesting thing. So this is running on Linux, right? So this is using the latest version of Ubuntu. If I was using it in production, I'd probably pin that to a specific version because you want to be immutability. If I run that pipeline a year from now, I want to get exactly the same build. So if I was doing this in production, I wouldn't use the Ubuntu latest. I would use Ubuntu 18, right, or a very specific pin version. And then if that changes, that's going to be a change and a commit in my source control. But for now, we'll start simple. And then the steps, one step here is just going to run a script, right? So this demo script, this is just a bash script. It's going to say hello pipelines, right? Okay. So we will deploy that. By the way, my web app finished deploying. So let's start doing 2 demos at once. So you have to sit there and watch the command line run. This is just a configuration item I have to set on that web app. So it knows about the startup.txt file, and now I can actually run that instance. So if I go back up here, lost my URL. Sorry, pull it up here. So just to show you that this is working, it's my Azure portal. Go to App Services. My correctly spelled Flask demo. And if I go to the web app here, same exact app we deployed earlier, right? Okay, but I did that manually. We don't want to do it manually, okay? So back to my source control. I've made this change here. I'm just going to commit that change here. I'm just going to commit all this. When I deployed through Azure, it also created some command line stuff or some config files. I'm not really going to use them, but I'll keep them in source control just to avoid having dirty commits in my local repository. So add pipeline starter. So this pipeline doesn't really do anything yet, right? Just says hello world, but I want to just push that, and let's configure our pipeline all the way through, right? Let's just make this whole thing run. So I'm back in Azure Pipelines, and I'm going to create a new pipeline. And I'm going to use GitHub as the source. And this is Flask Web App 2. That's the name of that project. And it's going to look at that repo and say, oh, you know what? Hold on. I missed a step. I didn't do a push. Okay. What it's asking here is it's saying I don't see anything here. I don't see a pipeline. So I'm going to go back and do this again because I'll already have a pipeline. So GitHub. No, it's not. Didn't find my YAML file. Okay. Usually it finds it automatically. Okay, so this is that same pipeline I had, and I have the opportunity to edit it here, but I'm not really going to do anything. I'm just going to run this as it is, right? So same thing, hello world, run my pipeline. Okay. Not very useful, but let's just test the path all the way through. Okay. All right, let's go back and look at my pipeline and see the problem. I had a syntax error, line 18. No. I must have mispasted something in my pipeline. Let's just strip this thing back. All right, so this Python is going to be able to, and it's now you see if I have another commit, if I watch it here, push, I think I pushed. If I watch here for a second, it'll successfully, or it'll run another instance of that pipeline. So what's happening here is GitHub has a webhook now to Azure DevOps, and that'll automatically start a build on a commit. The demo gods are cooperating with me today. Usually just takes a second. Make sure I'm on the, yep, that is the right project. All right. I'm not sure my build is not triggering right now. Let's move on, and then we'll see if this starts triggering. I'm not sure why that build isn't starting. Okay, so that's not a very useful pipeline yet, right? I actually want to do something in my process. So let's take everything I did in the command line before, the virtual environments, install the requirements, and let's bake that into my pipeline. So the first step is I'm going to delete this hello world script because that's not very useful. And the first step is I'm going to tell Azure DevOps that I'm using a specific version of Python. So this task item is a built-in task in Azure Pipeline. So you can think of that as like a script or a template that we provide for you to make things a little easier. So this basically prepares that build machine with this version of Python. Right. The next step is this build step, right? I'll install all the dependencies. So this is everything I did in the command line. So this is that I create that virtual environment. I activate that virtual environment. I install a few things that I'm going to need locally, including PyTest that we'll use later on. And that task name is dev dependencies, right? So this should run and build my pipeline. So and I'm kind of using a very simplified code flow here. We'll talk a little bit more about in a production environment, I'd be working a little differently. But for right now, everything is going to master just to keep things simple. Okay, so what I'm going to do is I'm not sure why that pipeline didn't trigger. So I'm going to, this doesn't refresh and oh wait, there it goes. All right. Got some kind of YAML syntax error here. I spend more time fixing YAML syntax than I'd care to admit. Okay, let me cheat a little bit and find my working version of this, just like with a cooking show. I have another version of this that's fully baked that we can get code from. So this is a more finished version of that pipeline. So I'm just going to take everything down to here because it should be the same. I clearly just have a character off, and I don't think you all want to watch me search for that character. Okay, so same thing, right? Same code. So I'm going to push that, and with any luck, I will have a green pipeline for my web app. Okay, so we'll give that a moment. So in all my kind of testing on this took about 2 or 3 seconds to trigger, and then, you know, Murphy's Law demo says that the more people watching, the longer it takes, right? So, okay, let's watch that build happen in real time. So all those steps that I showed earlier, each of those is going to run through here one at a time. And This is basically a workflow, right? So this is very common in CI and CD tools, right? So each of these steps is atomic. It's going to do some sort of work, and then finish and do the next step. Oh, I got ahead of myself. I pasted in my test code too. But you see that install dependencies task. So this everything I was doing through my command line manually now has been automated through my build pipeline. Right. We'll ignore this test area here because we'll do that next. Okay, so now I have a process that can build my app. Let's go back to the pipeline and deploy it. I'm going to take this test out. I didn't mean to include that yet. Okay, so let's talk about the process to deploy my code. So when I deploy to Azure App Service, the easiest way to deploy is just send it as a zip file, right? Azure App Service knows how to work with a zip. So that's a two-step process. The first step is creating the zip file itself. So now that I've built something in this directory and all of my dependencies are there and the virtual environment's there, I want to package that up into a zip file that I can send to the service to deploy. And this is a very important concept now. That this zip file is stamped with a build and version number, and that's kind of like a serial number, right? So let's talk about how that works. When you see this $paren syntax in Azure DevOps pipelines, that's basically a reference to a variable, right? So this variable is build.sources directory. So that basically is my that's my source path. That's where I was working with when I was working in these previous steps. I'm going to tell it I'm going to create a zip file, and then this artifact staging directory that's provided to me by the pipeline service. That's a holding directory for holding the outputs of this build, right? The things that I want to keep, because after this build runs, this VM is wiped out, at least logically speaking, right? I don't keep any of that. But in the meantime, I want to capture this artifact and as an output. So I put it in this folder and I tag it with this build ID. So this build ID is provided by the Azure DevOps pipeline. So if I go back to my build here, I see this number here. This is a build ID, right? So just like Pradeep was talking about stamping everything with a version, you want to stamp things with a version. You also want to stamp your deployment with a build, right? So I can go back and I can look at the code, the recipe, the tool, the environment, everything that we use to create that build. I can go trace back. So if there's a bug related to that build and I'm having trouble reproducing it, I can recreate that build exactly, right? I know exactly how that zip file was created. All right, so let's go back to the code here. So I'm going to create the zip file, and then Azure DevOps automatically knows that, wow, this is an artifact, so I'm going to keep this, right? So like, even though the rest of all that working directory and everything gets deleted, this artifact, this zip file gets kept and retained forever, or as long as you want to retain them. And the next step here, this is the deployment task. Now, again, a little bit of an anti-pattern, but we're doing one step at a time, is that I'm going to deploy this at the end of my pipeline, right? So if it builds successfully, I'm going to send it to production, right? You never do that, but maybe you do want to send it to a test or QA environment on a successful build or a certain tier, right? So I'm just showing this here. We'll in a couple steps here, we'll show you how to improve on this. So I'm not going to get too far into this because this isn't really an Azure talk, but this is basically, I'm using this variable I defined up here. This is the connection to my Azure subscription. I already have a secure key that gives Azure DevOps access to my deployment environment. So there's a service account or system account that has access to deploy things on my behalf. And I have this web app name that's used to name the app, right? So that's how it knows which website to deploy this web app to. All right, we got this, and deployment, check, push. All right, let's go back to Azure DevOps. So now, and I'm sorry moving through this pretty quickly because I want to show a couple more things in this process. So now let's go back to our pipelines, and this one's been triggered. So agents assigned. So what's cool, like this agent assigned, this agent is like a VM in the cloud, right? This is part of that 30 hours I don't pay for that I get free every month. So this is a VM that gets assigned to me to run my builds for me. So it's running through my steps. You can see that it's installing my dependencies. Here's those 2 new steps we just created. So if everything runs successfully, those will turn green as we go. And here's the other cool thing, right, is you have traceability. So if you had a problem with a build or some sort of error in the process, you can go back and look at the output of those command lines and build processes. So what I do in a lot of my pipelines is I tend to make them somewhat verbose, capturing the version numbers and everything else that's running. Because if I have a problem, I can usually go back and look at the pipeline process and debug my build from that pipeline if it's something I'm not building locally. Okay, and it says skipped here. It's actually just waiting. I'm not sure why it says skip. So that'll take a moment. We're not going to watch that run. That'll take a couple minutes, just like it did in the other servers. That's basically going to deploy the new zip asset, and it's going to recycle the web application. So great, we have a web app running, and we'll go back and show that here in a second. I'm not going to wait for that right now. But there is a bug in this web app, and I'm going to show it to you right now. Actually, I think it's almost ready. So we'll. So in my API, I have this number endpoint, and everybody knows that the magic number should be 42, but right now my API is returning 41, right? So I've caught a bug in my production environment. Obviously, this is a very contrived demo. I'm trying to keep the code as small and as simple as possible. But let's say, for example, this is a bug that leaked into production. So now I'm going to say, wow, I need to put some quality gates on my release process. I need to put some automated testing into my environment. So I don't, when I fix this bug, I'm not going to have that bug again, right? And that's a good DevOps mindset is, you know, I have two problems here, right? I have one, the fact that I have a bug, and two, my testing didn't catch it, right? So let's go back and take a look at how we can address that. By the way, I think our deployment finished. Let's go back and take a look. Yep, so everything ran. My archive file succeeded. So my entire, that zip file I was talking about, this is just my code. That is the entire virtual environment. So I'm not relying on that server having anything, or I don't care what that server has on it. Everything I need to run my app is deployed in that zip file, right? So here I'm using zips. I'll show you, if we have a little bit of time here, how this works in the container model. That's another valid way to deploy your stack, so you make sure that you're not going to be surprised with the works on my machine situation. All right, so let's go back. We're going to look at how we can address our quality issues. So the problem is that on this formula function, this magic number function is supposed to return a different value. And obviously you'd have real code here, but in this case it's returning 41. It should return 42. And I want to make sure that I don't have this problem in production again. So in my project, I've already built out this test folder, and I already put a test in here for this. So I'm using PyTest here, and this is, you know, a super simple test. Basically, I want to define this test as saying, when I call this formula magic number function, it should return 42. So let's add testing to our project. Let's not fix the bug. Let's fix the process first, and let's add testing. So I'm going to add a step to my deployment pipeline that's going to run this test every time I deploy. I'll try to deploy. So go back to my code, go back to my pipeline. So in between installed dependencies and archive files, I'm going to put this indented, my slide rule out. Okay. So got my script. So basically, this is activating the virtual environment, going to the app directory, and then running PyTest. I'm not dogmatic about tooling, and I think it's something that is, you know, a lot of it's personal preference. Some of it's based on your team. So I'm using PyTest here. Really, anything you can initiate through a command line with just about any testing framework is going to work well here, right? You know, find something that works, find something that's supported well in the open source community, and build on that. I'm using PyTest. So I'm going to save that. I'm going to commit. So this is kind of a cool cycle here, right? So I'm committing changes to my deployment process into my code pipeline, just like any other type of code. So add my test, git push, and we should get another run running. And this one, if everything works right, this build should fail, right? Because I added the test, but I didn't actually fix the bug. So let's see how that goes. All right, new build. And run through the process. So this shouldn't even deploy, right? Because remember I said that if any step fails by default, the whole pipeline fails. And you can put more logic in to do more things. You can put a failure path on here. You can make certain failures warnings, right? So if you have a like a dependency audit step, maybe that's a warning in your environment, maybe that's a failure, right? You have to decide what that is. Okay, so as we were hoping, run test failed, and I can see my test magic number test failed. So that's what I wanted, and my deploy didn't go, it skipped. All right, so let's go fix that now. Go back to formula.py, it should be 42. Save that. Oops. Fix formula, push. Okay. And now we'll get another build here, and that it shouldn't surprise you that that one will succeed and run. Okay. So a couple anti-patterns here, just for the sake of keeping the demo fairly simple. One is everything I'm doing here is on master branch. And in a developer environment of one, maybe that's okay, right? And maybe it's not. But certainly if I have other people on my team and I'm constantly committed to master, that as I'm fixing things and things aren't really working, that's not what I want to do, right? So that's not a really good team-based model. Also, I have one pipeline that's running everything here, one task that runs through the whole process. I'm probably not going to run automated deployments, and I'm probably going to deploy to more than one environment, right? So it's a bit of an anti-pattern to have my build, my CI process, which is responsible for checking my code and creating a deployable asset, and my deployment task running synchronously in the same pipeline, right? So what you'd probably do is have these defined as different jobs and then have them triggered differently, right? So there's some sort of quality gate between them. Maybe a human has to make a decision that, yeah, we're going to promote this from the test environment to the production environment. So what you'll end up having is multiple pipelines using the same definitions, but using the jobs in different ways with some orchestration and workflow between them, right? So you may have an approval, you may have more build and test automation, you may have some manual testing that has to happen between environments. So this task will be in probably its own pipeline and run multiple times as things get promoted from one environment to another. But we only have about 45 minutes here, so we didn't have time to build all that out. But let's take a look at how this looks like in another project. So we were using Flask here, so I thought, hey, let's take a look at how Flask does this. So Flask uses Azure pipelines. It uses Azure pipelines for all of its test automation, right? So Flask targets multiple operating systems and multiple versions of Python. So they have a pretty gnarly test matrix for any change that happens. And so this shows you some of the better patterns in terms of team software development for like a pretty good sized open source project. So you see things that are merged back to master, but a lot of the work is happening on feature or work branches. And every time something gets checked on one of those branches, that also triggers the build and test process. So let's take a look at one of these. Let's take a look at one that failed. So these are all concurrent builds on the Flask test matrix, right? And then a couple specific pipelines that address non-code or non-executable tests like style and docs and those types of things. So each of these basically runs on a different operating system and a different version of Python. And these all run concurrently. So remember I said 10 concurrent build agents. This is where that's really handy is we'll fire up 10 of these in parallel at a time and run through your test matrix and run all these tests. So you can see that being a mature project, there's a test matrix, there's some performance testing and all other kinds of things built into here. So as much as possible, you want as many tests as possible to run as early in the process as possible, right? Because if I can catch an error or a problem in a feature branch before it gets committed back to master, that's much better than having it fail on a deployment, right? So that's what the Flask project does. Is it has this the testing process and the CI process is integrated into the workflow in GitHub. So this for example, this won't be merged in until this issue is fixed. Right, so those are the quality gates in the process. So let's talk a little bit about the people aspect of this, because really this whole journey in organizations that I work with, at least, is 80% people, 20% technology, and this is how most of the teams at Microsoft build software now. Is we're structured in physical team rooms that are 10 to 12 people that are cross-discipline. So remember we talked about the org structure moving to more feature and product based instead of infrastructure based. These teams work, most of the dependencies are within the teams instead of cross teams. An important aspect is these teams not only own the development of the features, they own those features in production, right? So if there's a problem with this aspect of the product, there's somebody from that feature team that's going to be on those calls working with that issue, and it creates this good selfish behavior of, if I have to support this product, then I'm probably going to invest a little bit more in monitoring and telemetry, because I'm the one that's going to be dealing with the calls and the pages at night when my feature breaks, right? So it creates that nice accountability. And we talked about kind of org chart structure. So most large enterprise organizations are structured around horizontals. We've really moved towards structuring around verticals, right? So we don't have like a centralized DBA team. I mean, there are DBA teams that are focused on a slice across the product for standardization and performance, but features tend to own their own data, and they own their own stored procs or schemas and everything else, right? So they don't go to a centralized DBA team, and that's for agility, right? It lets us move faster. And then the structure. Let me kind of talk about branching a little bit, and then I'll go back to. I'm missing a slide. That slide. Here we go. It's hidden for some reason. All right, so our release flow process is, and there's a lot of good religious conversations around branching strategy, and I encourage you to, my encouragement is to use the simplest thing possible, right? Over time, this is what we've evolved to, right? Is you have topic, feature, hotfix, bug branches that are created. Those are short-lived branches that are there for the sake of creating a stable implementation and merged often, right? So these topic branches live for days or weeks. They don't live for a long time. And then release branches are broken off to track the code and implementation that we actually end up deploying after the environment. That avoids merge debt, right? Like that's from our lessons in these large monolithic development processes. Merging teams that have been working apart and code bases that have been drifted apart for a long time is death, and it's death to agility. It's death to deadlines. And so having a master in our world is always shippable, right? And I definitely encourage that mindset. And and the governance of that is done through pull requests, right? So this is the pull request is the workflow to get your feature branch or your hotfix branch back into master. And we have some human workflow there, and we have some build automation workflow. So just like with Flask, we have tens of thousands of automated in-memory, very fast tests that run at every pull request, right? So all the things all the foot guns we've kind of managed to find in the past should be covered by our test matrix. And then there's a human aspect, reviewer aspect there for code quality and sanity, and another set of eyes. And that's the merge process to get the code back into production within Microsoft. And talked about the test matrix. You can see that this is about a year out of date. So this is Azure DevOps. This is the team that builds the tool that we use to do the building. You can see that this is 78,000 unit tests. I think we're close to 100,000 on that team now. Like I said, this is about a year old. So that discipline is really important to letting us move quickly. So you saw my little hello world test case, and really that's where you start, right? Like don't try to get to 100,000 tests. That's not the quality bar for success. If you have 0, get to a dozen, right? And don't write tests for the sake of vanity. Write tests for the stuff that causes problems or has an impact in your organization, right? Use that feedback loop I talked about before to capture your learning. So the other thing that lets us move quickly are feature flags, right? So feature flags let us commit back to master before we're ready to show a feature for a customer, because it could take us multiple iterations, multiple weeks, multiple months to actually build a feature in a product. So how do I merge that back to master and ship master all the time and not have my customer use half completed stuff? And that's through feature flags. So at first, feature flags are used to disable a product that's not ready. And then over time, feature flags are used for giving preview access to opt-in customers over time. Then eventually, we flip the feature flag on the default. And then for a time, we may let the customer opt out of that feature for a while. And then at the end of the time, we'll permanently set that feature flag on or delete it. And then that feature and capability is launched in the product. So feature flags are, in our model, are not a nice to have. They're a gotta have for shipping a online service that's updated constantly. So it's an important part. And I'm not going to get too far on this, but because I think Pradeep covered it really well, is monitoring is just essential, right? So if there's a problem that caused me to have to SSH into a production environment or break the glass to access production, now I have two bugs. I have the bug that caused that issue to begin with, and I also have the fact that my telemetry and monitoring wasn't good enough, and I had to break the glass. So in our world, that's two bugs that added to the backlog when that happens. Telemetry is just as important as a feature for us. So in summary, how to get started, set goals, define your team, right? Think about the team structure I talked about. Try to align around features instead of silos. Source control is the critical starting point. If you don't already have good hygiene around source control and a centralized version of the truth, start there, right? I mean, you're going to get great benefits out of that outside of everything else that I showed today. And then start building your CI. Don't gold plate this thing. Start small. I showed you how you get started in an hour and get out some very basic build automation. And then over time, add deployment automation, add testing. Just try to add a little bit of improvement at each level, each iteration. And then telemetry is super important too. So anytime that you don't know about the health of every application, that's probably a good opportunity to add some telemetry. So I don't know how we are on time. I think we're close to our end. So I'll open up some time for questions as much as we have.